Welcome to Kaiju Mathematics. Today I will be discussing non-disjoint probability experiments, specifically with the word OR. When we are trying to understand what the difference is between non-disjoint and disjoint, we want to get a visual understanding. So I'm going to start this off by drawing out a Venn diagram with non-disjoint events. So we're going to have one circle here, one circle here. I'm going to use dice as my experiment here. We're going to call one event on a dice numbers less than, let's say, 3. So the numbers less than 3 on a dice are 1 and 2. Let's call the other event the even numbers on a dice. What are all the even numbers on a dice? 2, 4, and 6. These two events have overlap with the number 2. So the event, the numbers less than 3 on a dice, and the event, the numbers less, or not the numbers, but even numbers on a dice, there is overlap with the number 2. So these two events are non-disjoint. And when we have non-disjoint events, the formula that we typically look at is, I'll call this event A, and I'll call this event B. So we have probability of event A plus the probability of event B. And if they are disjoint, meaning there's no overlap, we just have the probability of A plus the probability of B. But in this case, there is overlap between the two events, so we have to subtract off the intersection between the two, so the probability of A and B. And here's another visual that I like to do with this kind of experiment. The probability of A, so the numbers less than 3, probability of even, 2, 4, 6, look what I just did. You see that? I just highlighted the middle 2 times. So I took the probability of less than 3 plus the probability of B minus the probability of A and B. And if we're just using this as our example for now, and then we'll look at a couple card examples, probability of A, in my case, the numbers less than 3, there are 2 numbers less than 3, 1 and 2 out of 6. And we can simplify that down to 1/3, plus the probability of event B, which I call the even numbers, that's 3 out of 6, minus the intersection between the two events, which would be that single number of 2, so 1/6. So 2 plus 3 is 5, minus 1 is 4 out of 6. Simplifying down to 2/3. So that is the formula for non-disjoint events. When we have overlap, we want to subtract off the overlapping area. So A plus B minus A and B. So let's take a look at a card question. So talking about cards, let's say I'm pulling one card from a standard 52 card deck, and I want to know if it's a king or a diamond. So I want to know if the card, what is the probability of the card being a king or a diamond? So we take the probability of a king plus the probability of a diamond. And this is where you have to know, are these events disjoint or are they non-disjoint? Is there overlap between kings and diamonds? And if you're not an expert on cards, you could easily just Google information about cards. Just know there's 4 suits, 13 cards a suit. Each suit has each card, so the same cards in each suit. So therefore, that means that we have 4 kings in the deck. We have 13 diamonds in the deck, but we also have a king of diamonds. We have that overlapping card, the king of diamonds. So I want to subtract off the probability of the king of diamonds. So the probability of a king, there are 4 kings in the deck out of 52, plus there are 13 diamonds in the deck out of 52, minus that single overlapping card, the king of diamonds, so 1 out of 52. We have 4 plus 13 is 17. 17 minus 1 is 16. So 16 out of 52. And you could write that as a decimal or a simplified fraction, one or the other. Do not leave it as 16 over 52 though. That is going to simplify down to 4 out of 13, and the decimal approximation would be 0.308. Typically, when we're looking at this experiment of pulling a card, like we want a single card or a suit, your answer is probably going to be this in most cases, just because there's the same amount of cards, there's the same amount of cards per suit, so it's always going to be 4 out of 52 plus 13 out of 52 minus that single card in these specific scenarios. I'm not saying that's the answer every single time you have a intersection between the two events like that, but I'm just saying in these experiments where you're pulling, you want a single type of card and a suit, it's probably going to be this number. So that's a good rule of thumb there when you're checking your answers. So I hope this helps with non-disjoint events, gives you an idea of what the difference is between non-disjoint and disjoint, and why we have to subtract off that intersection between the two events, which I showed you in this visual here, where we have this overlapping ground. So if I don't subtract off that overlapping ground, I'm adding them 2 times, and I don't want that. I just want that over that middle area just 1 time being represented, so that's why I have to subtract off that intersection there. If you like math and you like Calcudokus, please hit that subscribe button, and thank you so much for watching.